In this part we will be implementing the creeps. You can see that compared to our previous video, I've set some elements of our level. This is pretty much level design, so what I have wanted to do was having a kind of symmetrical level, and I will have my first player beginning in the top left corner, and later on, when we will be implementing the second character, we will put it in the bottom right corner. And those elements are just a basic layout of our level. You can pretty much go and make it as you want. Just make sure to have some squares and some corridors, if you will, where the characters and creeps will be able to move, and some explodables block for now are blocking the way, but the game will be made such that those blocks will disappear. And if we quickly have a check at it and use bombs to make our way, you can see that you are kind of designing where you are moving as we go along. So yes, the level has a bit changed since E-blocks have disappeared, and there is far more room for the character to move, and this is space that the creeps will also be able to move into. So let's go back into construct, select our layer background, and pretty much like the character, we will be inserting a new sprite made of several animations. So import not sprite strip but frames, import frames, and this time it will be the creeps. And so very much like the character, we have several frames from the side, and the speed of the animation will depend on the number of frames we have. So there it will be 7, and it will be looping, and this will be our right animation. Make a new animation, down, import frames, go into the front folder, and this time it's only 6 frames. So make the speed of our animation to only 6, make it loop, add a new animation, left, go again, importing frames from the side folder, always delete the first frame, and hold down the shift key and mirror, and finally add an animation up, import frames, back, 6 animations again. Did I change? No. There it's 7 and it's looping, and for the up it's 6 and looping. Here it is. So we will have to set our collision polygon, and this time it's a bit different. We have a 64 by 64 texture, and I will need to only remove a few pixels from it. So the first point is at 4 by 4, and then 60 by 4, and the Y at 4. Here it's 4 by 60, and 60 by 60. Here it is. And once again, we apply to all animations. Yes. And so for every frame of any animation, the collision polygon is set and is ready. And that's about it for what we need. The origin point will be in the middle, which is okay. And so we will have this object right there. We will rename it creep, and we will be adding a few behaviors. First behavior, I will be adding a 8 direction behavior, like for the character, and this will pretty much handle the collision with solids for us. And default controls to know, and that's about everything I need to change in this one, because it's really just to handle the collisions and nothing more really. And then we need to also add another behavior, which is the pathfinding behavior. To understand what pathfinding is, I will get back to this example I have had made a few years ago. You consider that your layout is a grid, pretty much like we've set our own layout, you know, with blocks and stuff like that. And you have a starting point and a destination point. And I will generate random obstacles, so the gray squares right there are obstacles that we won't be able to move through, and we can then generate a path. And as you can see, the pathfinding is directly calculating a path through the different cells in the grid and allow you to go from the starting point to the destination point. At the moment, the pathfinder is set so that it can move in diagonal, which is not what I will want for our game. So I will modify there the not cut corner, clear the path, and generate another path. And as you can see now, it will be moving this way along the path. So this is just a calculation of which cells to go through to go from the starting point to the destination point. The movement is also handled by the pathfinding behavior and will be a bit more automatic. And so I hope this helps you visualize how it is working. I can clear obstacles, path, generates more obstacles, and generate a path. And good example, sometimes you can't generate a path because it's not possible. Right there, as you can see, there is no way for from that point to that point. There are squares blocking everywhere. It's not possible to move through. So let's, for example, remove that obstacle there, generate a path, and here it is. The algorithm has calculated a path that allows us to move from one point to another. Our creep will always be the starting point, and we will be making a new kind of object, which I will put just right there, in which I will it will be very simple and it will be invisible for the player. So just a size of 16 by 16, put some colors into it, and that's about it, and rename it destination. And so this will be a destination point. This I will put a lot of them in the level, and the creep will randomly pick one of the destination points and try to calculate a path to this destination and move to it on a random basis. So for the destination, we just need to set it to invisible in the initial visibility property, and I can pretty much then just put them anywhere in the level, and it will be picked on a random basis. So those will be, it's not very visible, so I would change the color. Yes, here it is. We can see them a bit more obviously. And here, and one here. Still trying to keep it symmetrical. And so we need to modify a bit of the properties there. So the cell size, remember our previous example, there we will want a cell size from 64 because it's the main size we've been using, and the cell border, as you can see in the help there, an additional size to detect obstacles, but it's can also be actually it's not necessarily additional, it can be subtracted, and that's why I will put it to -8, which will mean that actually pretty much like the collision polygon there, which is a bit smaller than the size of the texture, the pathfinding will go into cells of 64 by 64, but to detect if an obstacle is in the cell, is in the current cell, we will reduce a bit the borders. So because if we just kept to 64 by 64, for example, where my creep is at the moment, this obstacle, this obstacle, this obstacle, this one, this one, this one, would be considered as being part of the cell that the creep is currently in. And so that cell would be considered as there is an obstacle, you can't move there. And obviously it's not the case, you know. There is it's a space where it's possible to move, it's walkable. So by removing some size to the border, we'll just check that a little square inside our cell, is there an obstacle in that square? There isn't, so I can move there. The obstacles property we will set to custom, because we could just keep to solid, but our some of our objects don't have the solid, and by using custom we will be able to set in the code what kind of obstacles are to be avoided. The pathfinder will generate a path, but it will also handle the movement along that path. And so the max speed is the distance in pixels per second that we will be traveling. So there I will put it to 45. I will change rotate speed to 135, it's good, but I won't want the object to rotate. Pretty much like our character, we will handle what animation to display depending on what is the current direction of the creep. And that's pretty much it for what we need. We can go into the code itself now. So we will make a group, name it creeps, and we will use still our function. So add a sub-event, function, and on function, and we will name it creep pick destination. Then we will add a sub-event. We will pick a random instance of the destination, and add another one, and this time we will pick the creep by its unique ID, and the unique ID will be passed as a parameter of our function. So when we will be calling creep pick destination, we will be applying this to only a specific creep, and we will pass the unique identifier of the creep as we go along. And then we will need to regenerate the obstacle map. So this means that anytime we will call this function, the pathfinding will calculate the obstacles. So because our bombs there will be considered as obstacles too, and as the bombs can be planted, can explode, and when exploding some blocks can disappear, the obstacle maps will need to be recalculated to see if the creep can go or not. And we need another action, which is find path to destination.x, the random destination we've picked in our event, and destination y. So this destination. And we will also need to add a few instance variables to our creep, which will be direction, pretty much like our character, and by default we will keep it to 0, and we will also add a current dest x and a current dest y, which will be a variable in which we will keep the destination we are going to, and so that's where we set it. Set the value current dest x to destination x, and pretty much the same current dest y to destination y. We will add another event, and this time it will be a system on start of layout, which means that this event right there, and we will put it at the top of our event sheet, will happen at the very beginning, when we are loading our game, our level, actually only the level, and this one we will add some obstacles. So add obstacle, and there we want the E block, we also want the block, and we want the bomb to be considered as obstacles. Here it is. Add there a sub-event which will be a for each. For each is another type of loop, and that will go actually through all the instances of the object type we chosen. So for each creep, which means for now we only have one, but let's put there, and we have two. Let's make sure our properties are okay. Oh, I forgot there. Diagonals are to be disabled. We don't want the creep, for example, if that block there was going, it could like move, at least try to move in diagonal, and would actually get stuck because of the 8 direction behavior. So we don't want them to move in diagonal, and only be able, like our character, to move up, down, left or right. So it's disabled, so it's good. And for each creep we will call our function creep pick destination, and we will add as a parameter the creep.uid. And so this will be called for every creep. So if we add even more creeps in our level, this loop there would just make it so that every creep is trying to pick a destination point, one of the green squares, at the beginning of the layout. And then we will add a sub-event in our creeps group, and this sub-event will be once again from the pathfinding, and it's on path found. So there, remember, find path. This action, if it's successful, that is to say that it's finding a correct path to the destination point, this event will be triggered and will happen. And what we will be doing is simply creep move along path here in pathfinding movement. That's it. And when our creep on the other end won't be able to find a path, so creep on failed to find a path, we will actually simply be trying to pick another destination. So it will kind of be an endless loop where creeps will be trying to access some points, and if they can't access those points, they will try to pick another point until they find one where to go to. And finally, add a sub-event creep, and when you are arrived, so once the object has finished moving and is arrived to its destination, very much like previously, we just wanted to pick another destination. That is a very simple AI that is kind of dumb, to be honest, because it will be simply moving and trying always to pick a destination point and go to these points. So I will be adding more destination points, and if I'm trying, you can see the objects are moving. So at the moment there is nothing but the right animation. The creeps are moving. They are trying to pick one of the destination points that we can't see in our game, obviously, and they are moving through it. And once they reached it, they try to go to another. And something we don't see at the moment, but it's likely that when it's trying to pick some of the points at the moment, it may be trying to pick a point there or there or there, and our on failed to generate a path event kicks in, but it's completely transparent. We don't actually get to see it. So let's go back to our project, and now we will be handling the direction and the animation of our creeps. So add yet another sub-event, and this time it's when creep is moving along the path. And we will also want to add another condition and put a for each creep. So we will the sub-events we will be adding right now will be executed for each instances of the creep object. And add a sub-event, and we will be checking, so comparing two values. The first one will be the creep pathfinding moving angle, and we'll first check that it is greater than dir up minus 25, and at the same time it is less than dir up plus 25. So actually I'm checking for a range, because we don't really see it, but the pathfinding behavior is trying to it not necessarily is really on point, just up or down, and we're still using our constants there, you know, so they're up to 2070, and when it is such, so we will set our animation to up. And so if I'm trying right there, here it is, it has changed. As it's the only event I have at the moment, the animation is not changing, but you can see that's what we want. And so we will be simply copying and changing, and this time we will check for down and down and set the animation to down, and then check for left, left, set the animation to left, and finally right, right, and animation to right. Here it is, and we will add a function that we will name, let's have event function on function, which is creeps region map. And yet again, it's for each creep, so just take this condition there. And I will want to regenerate the obstacle map, and I will try to find a path to our self dot current dest x and self dot current dest y. That's where we are using those variables, and when there will come in handy. I'll just move the function there. The position of the function doesn't really matter since it's being called from somewhere in the code. And this function will actually be very useful in several spots of our code. And for example, it will be useful in when we are planting a new bomb, or when a block is disappearing, because we want to regenerate the obstacle map and nevertheless still try to go to the current destination that has been picked. And so I will be adding a simple call up there. Function, call function, creeps region map. Creeps region map. Yes, when using function, make sure that the name you are setting there is very much the name you are using when calling a function. Otherwise, you can end up and ask yourself, well, I'm trying to call, for example, creep region map this way, you know. Once again, it's not the same name as with capitals letters. It's still using the, it's still case sensitive. Bomb group, when a bomb gets destroyed, I would be calling the same function, and in the power-ups group too, I think, yes, there it is, power-ups, when an E-block gets destroyed, so it would regen the map as well. go back into our explosions, and now we will want to check when an explosion is overlapping a creep, and we will be wanting to destroy the creep. Add an event that when a bomber is overlapping a creep, it's getting destroyed too. The bomber, that is. The bomber gets destroyed. So from now on, you have to avoid the creeps if you want to survive. I will also go back to our power-ups and change it there, the random var, and set it to 1, and actually to equal to 1, so that not every blocks. Oops, I'm dead. Let's go back. Here it is. The creep is destroyed. Nice. Yet again, destroyed too. And so now we can just destroy every blocks and we're free to move. So that's cool. It's working as intended. And that's about it for the creeps implementation. They are moving along the path. So yeah, to get back once again on the pathfinding, it's a pretty dumb AI, but it's doing the job, and yet I haven't tested. So let's check if our bomber is now touching a creep. Yes, the bomber destroyed. If you need more information or more understanding on the pathfinding behavior, be sure to read the manual article. That is pretty complete, and as you can see, as some visualization. And you can also test directly in Construct when you are making a new project and use the pathfinding. You have 2 demos you can use and test out. In the next video, we will be finishing our game by making menu layouts, and we will be implementing the second player, and we will also be adding the finishing touches to our game. So see you in the next video.